The gentleman to my left, putting his phone on silent mode, is Dan Jenkins. It's Chief Ape.
Chief Ape?
Yeah. I understand he's Chief Ape.
At Nimble Ape.
Nimble Ape. At Nimble Ape, he is the Chief Ape, which is pretty special. It's time to get physical with web, Bluetooth, in the browser. Give a warm welcome to Dan Jenkins.
Cool. Can everyone hear me? Yeah? Good? All good. Okay. So, I'm Dan Jenkins. Dan_Jenkins on Twitter. If you want to follow me, get my count up, that's good. The other stuff is less interesting, so let's move on. So, yeah, this talks about getting physical. Physical? No? No one? No? That's really funny. Anyway. So, you get it. Good. So, who's ever wished that they can go and stand next to an object, a physical object in the physical world, and be able to click on that object to find out more information about that thing using the web? So, who's seen something like this with QR codes? So that's the Hard Rock Cafe in San Francisco. That's another QR code from the prison in San Francisco. Anyway, so QR codes are everywhere. But they're really annoying, aren't they? You have to download an app to be able to use it. Or maybe you might use a progressive web app that's already out there. I don't know if there's any talks about progressive web apps. If you're interested, come see me. So yeah, you fumble around in your pocket and you download an app that you're only going to use like the once, and then maybe in like a month's time, you'll scan another QR code. But QR codes are actually inherently insecure as well, because they could kind of send you somewhere completely wrong. Like, so you scan a QR code on the back of a electrician's van. Like, how do you know that it's actually going to take you to the website of the electrician van? You don't. Like, so they're actually very, very insecure. So, there are many, 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 many places that we want to be able to interact with something. Whether or not that's a bus stop, there's a physical bus stop, and it has information, like that bus route, and it knows when the next bus is coming, etc., etc., etc. At a museum, at the cinema. So we can connect to physical things around us, and it's called the physical web. So the physical web bridges the real world and the digital world, the web. You can walk up to something today that's emitting a physical web URL, and you can interact with it. It takes you to a website, and you can use it. You can go get more information. So, like, what if the BB-8 Sphero emitted a URL, and you could go and play a game with the Sphero, and you kind of you've gone to the device, and the device has shown you where to go to play that game, to interact with it, and it's taking you there. An advertising sign. Well, I mean, there's a website on this advertising sign. Why should I have to, like, type that URL in? I'm going to interact with it. Movie posters. So, how can we go about doing this today in real life? You can use this on Android and on iOS. And we have what are called beacons, Eddystone beacons, and they emit a low-level URL using the Eddystone format. Chrome/Android, depending on your OS, picks up on that URL and does some magic with it, and then notifies you, shows it to you, and then it says there's something physical near you, and you can go and interact with it. So, demo. Like, let's stop talking about it. If you've got Android on your phone, then you can you can take out your phone today, put location on and Bluetooth on, and you should, theoretically, in the next couple of minutes, you should see like 3 web beacons. I think it's 3. One of the EMF schedule, so you can interact with the schedule. My phone is actually broadcasting this. Another one for my talk slides. Maybe there's only 2 at the moment. I'll put more on later. So, yeah, you can do this with Android or iOS. On Android, you have to have location and Bluetooth turned on. And it used to be that Chrome did all this work, and now Android does it for you using Android Nearby. And so you'll get a notification on native notification to tell you about the URLs. On iOS, you need to have your Bluetooth turned on, and you need to have Chrome notifications added into your notification center. So this is an example of, this is how I'm broadcasting URLs without physical beacons. It's called Beacon Toy on Android. But I could have quite easily put a URL onto one of these. This is a beacon, and you can set up how powerful it is, etc. Less powerful, and the battery lasts longer. But people within it will only get to people within a certain area. Whereas you can have it emit lots of power, using lots of power, and the battery will die very, very quickly. So yeah, you should see on the left here. You should see what you should be seeing. Hopefully, someone tell me you're seeing this in. Yes, good, awesome. So yeah, in that screenshot, we've got the schedule and BB8 control. So that's something for later. So yeah, how do we use this? So the beacon emits a Eddystone URL. The mobile device scans for those URLs in the background and displays a notification. Before it displays the notification, it sends it up to Google, and Google does some stuff. But gets displayed to you as a notification, and the user taps that notification, and it takes you to the website. There are some limits, which I can talk to you more about in a sec. So yeah, Eddystone. Eddystone is a standard, and there's quite a few different Eddystone formats that you can have. This is the URL format. So it's an open message format. A few different parts to Eddystone, but we care about the URL. And Eddystone URLs have 18 bytes worth of information. That's not a lot of information. And so typically what we end up doing is shortening URLs using like Google URL shortener. And then when the phone reads it, it reads that redirect and actually shows you the correct URL. But the actual device needs to only send a maximum of 18 bytes. Eddystone itself is supported by over 30 vendors in the world, and they're actually doing crazy things. Like, I think so. One of these you can buy one of these that's like completely and utterly waterproof, and it lasts for 10 years. In a really small device. So that's pretty neat. Eddystone is also compatible with iBeacon. I mean, no one actually talks about iBeacon anymore, but it is out there. So yeah, if you want to know more about it, then there's a link to it. So yeah, Chrome. So Chrome on iOS does the scanning. On Android, it does less work now. It's all passed onto the underlying OS. It was different about 2 months ago, and it all got switched. So Chrome only supports HTTPS URLs, so that's one limitation. The Chrome team are driving the web towards a secure web, and so you can only broadcast a URL if it's HTTPS. Chrome then sends those URLs up to Google. They have a proxy service, and that proxy service does some magic. It removes duplicates. So if I had 5 beacons in this room right now, all sending the same URL, then it would Google would actually get rid of those duplicates for us. Does more than just duplicates, like spam. If someone reports a URL as a spam, URL, then Google will actually stop it getting back to you as a notification. I think it does some other stuff as well, like can reorder the notifications depending on like where you are, and anyway. And it's not just Google that could run these proxy services. Like if Firefox implemented this into Firefox, or Opera are implementing it, then they run their own proxy services. It's not a Google kind of black box that no one knows about. So yeah, the proxy service then sends it back to Chrome or the OS, and Chrome/nearby shows a notification, and that's it. But obviously, to be able to send it up to Google, you need to have data. So earlier on today, I have a phone that doesn't have any data on it, and I hadn't hooked it up to the Wi-Fi, and so I wasn't getting any notifications. Android is very clever now, and it says, oh, you're not getting any notifications because you haven't got any data. So it's actually quite useful. So yeah, you could have this in a parking meter, or a train, or a bus, or a vending machine. And then you can start interacting with it. You can like see current statuses, etc. So when you add in progressive web apps so I talked about progressive web apps earlier a little bit. They're the next thing for mobile web. And so yeah, when you add in progressive web apps, your reason for building native apps now kind of dwindles, because these things are being used today. Before this was kind of implemented in Chrome, etc., you would have had to have a native app that kind of searched for Bluetooth devices, etc., and showed you some information. But yeah, physical web beacons are being used today. In London, we have buses that have beacons on board, and so those beacons are unique to the bus, and you go to a URL that is unique to the bus, and it tells you information about the bus. And so we get a nice, here's a route 10, etc., and we're at this place, and do you want a reminder for when you get to a certain stop? So this is a progressive web app in itself, but the fact that you can now kind of access it, you don't have to search Google, and you don't have to know the URL. You've gone to a physical thing, in this case a bus, and you're able to just kind of tap on the URL because it's related. And there's beacons here today. So I said my phone is actually emitting URLs right now. One of them is the slides, a link to the slides that I've already put online. Another one is the EMF schedule. So there's much more that we can start doing with the browser to make it physical. So there's a thing called Web Bluetooth, and this is something that I'm very, very excited about. I think it's actually going to completely change how we can start actually writing useful apps, web apps that kind of talk to real life things. The web has always been very, very separate, and now it's kind of merging into all these physical things that we can now start doing. So your browser can now connect to Bluetooth low energy devices directly. So this is being written into Chrome, and the Opera team are also working on it. Firefox had an element of this in Firefox OS, but it's never made it into Firefox itself. But now that Firefox OS is kind of dying or /dead, I expect it to start getting there. So it's a specification, and people are working on it today. So yeah, using JavaScript, we can now connect to physical devices around us and control them. So back in December, when Star Wars got released, I bought a BB-8, and I played around with it. What I ended up doing was controlling my BB-8 using web audio. So I'm going to show you a quick video that has some audio. So hopefully this is going to, yeah. The audio is not very loud, but oh, there you go. So you can see I'm playing the Imperial March using web audio, and then I'm analyzing the Imperial March as it plays. And when a beat change or a note change happens, I send a signal to my BB-8 using Web Bluetooth to change the color and to dance a little bit. Yeah. The first time I did this, ironically, I actually used Imperial March, and about 5 hours later, it got taken down off YouTube because they're sports. But never mind. So yeah, there's a blog post on my website if you're interested. But yeah, let's take a look at some real life demos here today that we can actually start playing around with. So I've got a microbit here. So the microbit is a really cool device. It has Bluetooth built into it, it has accelerometers built into it, and it has a nice LED panel built into it. And so maybe if Phil can come over here. You don't have to come up. Right, here's a phone. So I'm going to enable a beacon for the BB-8 demo. So hopefully, if you press refresh at the top, it will happen quicker. And so hopefully, if the internet works and everything hasn't failed, you should get to a little page that tells you to connect. Microbit, yeah. Got it? And it should tell you... Oh, never trust Phil to do anything for you. So... Oh, I enabled the wrong thing. So it's my fault. So I'm just scanning again for... Demos. They never work. Okay, I'm going to skip that step. And I'm just going to go straight to the website. Microbit.ngrok. If you don't know what ngrok is, go Google it, and you'll love it. So I've got... No one will be able to see this, really. But I've got a page here that says microbit LED scrolling text. And so I can send some text to my microbit using Bluetooth. So if I send that... No, it's not working. Send. Could not connect to my Bluetooth device. Why not? Chrome beta. So you have to have a flag enabled. In Chrome at the moment. Stupid LG phone. So this worked earlier. Microbit. Dot. Oh, I know why. I wasn't on HTTPS. So you have to be on an HTTPS page because we like security now, and it's really important. So https microbit.ngrok.io. So hopefully now, come on, send. So on my phone, it's come up with a prompt and said, what device do you want to connect to? I select the microbit, and then I can send it some text to display using Web Bluetooth. So that's a standard service. That's a standard service within the microbit. You can just send text, and it will automatically kind of do all the magic to put it into LED, into LED form. So that's the microbit using Web Bluetooth. So yeah, go buy a microbit. They're really, really cool. And the fact that they're 12 quid is a bargain. A drone. The drone can't do too much damage. So, I mean, let's give it a go. Let's give it a quick go. So, I've just enabled it, and then I've just plugged in the battery. Scan. So I'm trying to do it properly this time. So here we go, drone demo. So it came up as a notification, and I can connect to it, and it's scanning, and it's there. So I'm going to pair to it. Connecting, 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 connected. So now, so that's using the browser. There's no native code here. There's no native app. The browser told my drone over BLE to take off. I can tell it to flip. Okay, some propellers came off. I won't try and fix that right now. But the nice one is a, what's this? This is a BB-8. And I'm going to, just because it's cool, I mean, scanning, BB-8, connect. So it's gonna BB-8. Yeah. So oh, you can't see the lights because of the light. So I'm connected apparently, but the light's turned off, which is a bit connect, pair. There we go. So I can control the color of BB-8. I can make it green, or I can make it blue. I can aim the BB-8, so I can tell it what's the back. So this is very much like the native app. And then I can drive it using JavaScript. That's pretty cool. Like, I don't care who you are. That's cool. Right, so that's the demos. So how do we do it? So BLE, it's not just toys, although toys are really fun to demo. Heart rate trackers. Most heart rate trackers are BLE. My Fitbit is BLE. And so they all carry standard services. And so I can start kind of integrating them into my code. So there's fitness trackers, there's Bluetooth printers, there's more games, more toys. There's actually a lot of toys that are BLE. But there's a lot of devices out there that we can start kind of manipulating with JavaScript. So I'm talking about BLE, but some people in the room might not know what BLE is, so let's take a step back. So BLE is low bandwidth, and that's kind of its big thing. It can transmit 0.3 megabits per second, and compared to Bluetooth v3, which is 54 megabits per second, that's a huge difference. But the fact that it's low energy is the fact that it can only transmit so much. As I said, there's a set of standard services that we can talk to. So there's a heart rate service, and you can go and interact with it, and it's standard. And so if you had a heart rate tracker from one brand and another heart rate tracker from another brand, in theory, the same code would work for both because you follow the same service. Same with battery status. You can get battery status is a standard service. But yeah, you can build your own services as well. So that's what the Sphero team, when they made BB-8, did. There are no moving forwards and moving backwards and changing color standard services. So they made their own. Within BLE, you have something called a GATT server. You don't need to know what it stands for, etc. But basically, within the GATT server, you have services, and they might be standard services or custom services. And then you have characteristics within that service itself. So within the battery service, there's a battery level characteristic, but there could be a battery temperature characteristic. It's all handled by the service itself. So let's take a look at the Web Bluetooth API. So it's promise-based in JavaScript, and it's really, really simple. So you can see here, I'm doing navigator.bluetooth.requestDevice with some options. So this has options, and it says Okay. So I'm passing in, I want heart rate services. So we do a request device. That prompts us, puts up the little display on the page and says, what device do you want to connect to? You select what device you want to connect to, and then you can connect to it. So yeah, there's the heart rate tracker, and it prompts up a little display and says, which device do you want to... These devices match your filtering. What do I want to display? What do I want to connect to? So we connect to it, and then we can go get a primary service. So the primary service in this case is a heart rate service. And then we can go get a characteristic from that service. So these are all just promises. Like, I mean, there's very little here. Like, you'd end up probably like expanding all of these and logging some things at the same time. But this is very, very simple. So you go get a characteristic, heart rate measurement, and then you get that characteristic as a value. So that characteristic, you can then add an event listener to it to be told when it updates. So the heart rate tracker is a great example of this. Your heart rate is constantly changing. Well, not constantly, but it's changing. And so you get told, you get pinged a message every single time that the value gets changed. So you add an event listener, and then you start notifications. You have to tell it to start telling you about things. But what if the device was broadcasting a URL where it can be controlled from? So what if the BB-8 sent its own URL and took you to a website, and from that website you can control the BB-8? Exactly what I did using my phone. Why can't the BB-8 do that instead? Well, that's possible today, but we actually have no way of kind of bypassing that selection. So you know that prompt comes up and says, what device do I want to connect to? Well, I mean, I've just come from a URL from that device. Why should I have to then like select that device? That's kind of, it sucks. But the people making the specification have realized this, and there's something coming to fix that. You can now, well, soon you'll be able to do navigator.bluetooth.referring device from when you in your JavaScript to tell you, yeah, I came from a URL and it's this device, and so you can connect straight to that device without having to prompt for interaction. So where can we start playing around with Web Bluetooth today? I mean, 2 months ago, this was a very different story. 2 months ago, it was Android M and N, Android L with Chromium. Don't even, like, unless you're really comfortable, like, you have to, like, unpack a APK, and it's just effort. So unless you're really stuck on Android L, like, don't even bother. But a month ago, there was Android M and N and L with Chromium, and Chrome OS and Linux. I mean, most of my developer friends, we all use OS X because, I mean, we're web developers and we like OS X. So developing with Web Bluetooth was actually really tough because you had to have a phone doing all of the work for you, and you had to then connect a USB cable, and then you had to have Chrome like inspecting that tab as a remote device. It was a pain. But in the very in the past month, I think, OS X with Chrome 53 supports 99% of everything that you can do within Android M and N and Chrome OS. The only thing you can't do is turn off notifications. So some more information here. So yeah, you can see there that Android supports everything, but Android itself doesn't actually support stop properly. And OS X supports everything within Chrome 53. Chrome 53 is actually in beta right now, and so within the next month, it should be within general Chrome that everyone can use. But go start, like, if you want to go develop something, go download Chrome Beta, and it's like really easy, and it runs as a separate app. You don't lose anything within Chrome. Windows has very, very little support, and iOS has nothing. But you still have to enable it within Chrome. So you go to Chrome //flags, and then you enable Web Bluetooth. That's a slight lie. You can now have, there are origin trials going on right now. And so I could put any of my URLs that interact with Web Bluetooth into that trial, and you wouldn't have to enable that flag. So that's real life kind of testing going on right now, and that's a really nice step forward. Like I said earlier, my demo didn't work because I wasn't using HTTPS. So it only works on HTTPS, and it does work on localhost. So there's the secure origin type thing within Chrome. So there are quite a few hoops to go through to actually develop something that integrates into Web Bluetooth. There's less and less steps than there were 2 months ago, and that's really nice to see. So there's loads and loads of demos out there. So go to webbluetoothcg.github.io/demos. A lot of the Google team are making these demos, and members of the community are making these demos. My microbit demo will be going on there once I fix the pull request. But what devices are out there that we can actually program to do what we want to do? So I already showed you the microbit. The microbit is cool. Go buy one. But there's Arduinos. So I got a nice little Arduino from SignalConf from Twilio. That has BLE built into it. And so I can write today to like go out onto the display, or so like if I did a LED type text thing, it could go onto the display, or like this has a 3-axis accelerometer, and so when I chuck it up and down in the air, it can show that on a web page, or you can instruct it to go and do something with I/O pins to make something happen. I don't know. So Arduino, they're really quite cheap in comparison to, say, a Tessel. So a Tessel, you write Node, and you control hardware using Node. So this has loads and loads of modules that you can go out and buy. So it has a BLE module, and so I can emit a URL, and I can actually control a device using BLE using the Tessel. So this has like an accelerometer, and it has ambient temperature and noise. So if you want to get started and write Node instead of something else, Tessel is very good. And the latest Pi comes with BLE built in as well. And so, you can go buy yourself a Pi. If you want to get started with something, go buy a microbit. They're 12 quid, and they have loads of stuff built into it, and you can go play with it. So in the past 2 months, developing for Web Bluetooth has become so much easier, unless you're developing on Windows, but I mean, I don't feel sorry for you at all. Hardware with BLE is really cheap now. I think there's a board coming out that's going to be $5 that has BLE built into it. And so you can go build stuff yourself, and you can control it using the web. And as a web developer, that's really exciting. It's something that we haven't been able to do, and we've always had to kind of offload it to a native app. And then with progressive web apps coming along, making the whole mobile web experience so much better, we can actually start making these awesome experiences. So you don't need Chrome OS now or Android. You can develop on OS X. I forget that Linux was in that column. Who develops on Linux? So this is a really nice thing. So this beacon has a different kind of thing on top of it, and it's because it emits a GATT server. So it's a beacon and a GATT server, and so we have the GATT server runs a configuration service, and so we get into this kind of circle of life, where the Eddystone URL for this device is the URL to configure the device. So I'm emitting the URL to configure the device. It's emitted using Eddystone, and it's picked up using physical web. And then I go to that website, and I can configure this beacon using Web Bluetooth. There's a whole circle there. I never have to download a native app or anything like that. It's all within my web browser. So we can build things with the web now. We've been able to build things with the web that are very, very separate to the real world for a very, very, very long time, and the web's getting better and better and better. But there's less and less reasons to build native apps now. And I think we should all kind of, as a web developer, this is so exciting. And it takes away one of those things that like native developers kind of lord over you. If you're really interested, then you can go to this URL. This URL is a YouTube playlist of 3 amazing talks from Google I/O about the physical web and web Bluetooth. In one of them, there's a candy machine. Candy, that's so American. There's a candy machine, and you can control it using web Bluetooth. And so you can go to your phone, and I mean, it doesn't take any money. I mean, it's a bit of a problem. But you can go to your phone, and you can press a button, and it shoots out loads of Skittles. I don't know. I think that's cool. If you want to have a look at these slides again, then they're online using the URL that I'm broadcasting. Or I'll make it public and I'll tweet about it later on at Dan Jenkins, at Dan_Jenkins. Or locally, you can go to content.emf.camp/Dan Jenkins, getting physical with web Bluetooth in the browser. And I guess just as a quick side note, NimbleApe are hiring developers. So if you're interested in playing with this stuff, as well as loads of other cool stuff, then come see me. If you've got any questions, come see me outside, I guess, because questions in this kind of arena just don't work. So yeah, come speak to me afterwards. And yeah, thank you very much. Thank you.